Here's one more problem from section 6.3. This is actually very similar to the one that we did in class where we were rotating or revolving a region about X and also about Y, just to see which is bigger, and really no one cares which is bigger. The exercise is just to try doing it both ways. So let's do it about Y because that's the direction that is more concerning, I think, to people. So it says it's first quadrant region, which means it's in the positive X and Y direction. 4 minus X squared looks like that. So this is 4 up here, and this is 2. So 2, 0, and 0, 4. If I give it both coordinates, the region is this stuff. They say just use the first quadrant region. And so they're asking us to spin this around the x-axis, see how much volume we get, spin around the y-axis, see how much volume we get. So let's go around the y-axis. That's the more challenging direction. And you can do it the other way for kicks. So a horizontal slice would be what we would need to spin to get this around the y-axis. And if I spin that horizontal stick, I'll get a disc shape. So when you spin it, it's going to look like that, with a little bit of thickness, with the center of the disc is the center of the rotation right there. And so the radius of this disc is exactly the length of that stick, just like it was in the previous problem. All right, so I need to be able to measure the two ends of this stick so that I can transfer those measurements over to my disc. And those measurements, as we know, as soon as we start slicing horizontally, then those measurements are going to be in terms of y. So something comma y, and on this side we'll have 0 comma y. The reason I know that is because the choice of where to draw that horizontal slice is by choosing what value of y to draw it at. I could draw it at height y equals 1, and so the y coordinates would be 1, or at y equals 2, or at y equals 3, even all the way up towards y equals 4. So for any value of y between 0 and 4, I could draw a slice. And so that's why my variable that makes all this happen is a choice of y. So the reason that that matters in this problem, the reason why it's significant, is that the equation that I have to work with is not written as x coordinate equals some formula with y coordinates. So I have to do some algebra first, but it's not a lot of algebra. I just need to solve that equation for y. So if I add x squared to both sides, it looks like that. And then if I subtract y from both sides, it looks like that. And if I take the square root of both sides, I would have plus or minus the square root of 4 minus y. But because I know that the point is in the first quadrant, I know that the x's and y's are all positive, and so I don't need to worry about the plus or minusness of that. The only possibility is x is positive square root of 4 minus y in order to get the shape that I see. So that means, let me give myself one more room here, that my x-coordinate is the square root of 4 minus y, and my y-coordinate is y. Okay, so the radius of this disk is exactly the length of that stick, which is the difference in the x-coordinates at either end of the stick. So that x-coordinate and that x-coordinate determine the length of that. The difference of those is the radius. And so that is the square root of 4 minus y. So therefore, the volume of this disk is approximately pi times the radius times the thickness. And so therefore, when I sum up all those volumes, that'll be my estimate for the total volume of the solid. And then in the limit, the sigma becomes a big S. The pi is just pi. The square root of 4 minus y squared, well, that's just 4 minus y. If you take the square root of something and then square it, you're going to be back where you started from. and the delta y becomes dy. And so this is an extremely nice integral. Values of y going from 0 to 4. And so even I am brave enough to do this. So pi times 4y minus a half y squared, evaluated from 0 to 4. Which will be pi times 16 minus half of 16 minus pi times 0 minus 0. And so ultimately I have 8 pi. If I wanted to rotate this the other way around the x-axis, I won't do that one all the way to the end, but let me, still green. Let me just make sure the setup is okay. The first thing I would do is not use that same picture, although I can't seem to erase. Yeah, there we go. Why am I erasing that? Well, I'll just draw it again. So it's still this region, but now if we're rotating it around the x-axis, that means I'm going to draw my stick this way, which is going to make everything be measured in terms of x. So in particular down here, I have x comma 0. Up here, I have x comma 4 minus x squared, because in this case I do have the equation written as the y coordinate is equal to 4 minus the x coordinate squared. So when this guy spins around the axis, it becomes a disk shaped like this way, but the radius of that disk, it's got a little thickness to it, the radius of that disk is the same as the height of that stick. So the volume of one slice is approximately pi times the radius squared times delta x. And so the sum of all those volumes of the disks is going to be my estimate of the volume of the solid. So when I sum all those up in the limit, that becomes the integral of pi times 4 minus x squared dx. And the values of x here are 0 to 2. So I won't do that one the rest of the way out. It's also not terribly hard. I would recommend that if you do that one, you don't try to integrate using substitution or anything fancy. Just multiply, just multiply out 4 minus x squared. So that's 4 minus x squared times 4 minus x squared. And just use the distributive property. 4 times 4 is 16. Minus x squared times 4 is there twice. And minus x squared times minus x squared is plus x to the 4th. So don't mess around with this, just multiply it out. And now you're integrating a polynomial, much easier.